Okay, we are on air. I'm Ray, and we've got Jason from OpenPNP and Rame, who I'm hoping.
Graham.
Say it again.
Graham.
Ram. Okay.
Ram.
Yeah.
There we go.
Ram. Okay. Yep. So we're all on air.
Yeah.
And we're going to be deconstructing this little thing right here, which is a holder for a nozzle for pick and place. So this is a Juki nozzle. Yeah, I'm still working on making sure I get the correct frame for my camera. So this assembly right here. This assembly right here, combination of a hollow shaft stepper motor, the holder, and the nozzle, which again is hollow and has this little opening right here. This combination will go down, pick up a part using suction, move it to where it needs to go along with rotation, and then place it down on a circuit board and repeat this process until we have a completed board. And we just want to take this black thing and figure out how to make it ourselves. So hopefully that's a sufficient description for the viewing audience.
I think so, yeah.
Cool. And let's get to it. Okay, so we've got the set screw right here. That comes out, that's M3. I can get the length of that later. Now, the drawing that I sent you guys, it has a little nub here that sticks out a little further. And I just took that off the hacksaw because I'm using a NEMA 8-stepper, as a lot of us are.
Yeah.
And the shaft is just really short, so you can just barely make it.
Yeah.
See the hole. Where's the hole? Yeah, so the hole of the set screw. That'll just barely make it.
Jason's had that whole move, hasn't he? Further closer towards the end, so we can down onto it.
It's still 3 millimeters, but there's an additional section that goes like this.
Yeah, that's right.
And we've removed that.
That's right.
I just saw it down, so he's removed that. But it's still 3 millimeters from the widest. From the thing that's the widest.
Yeah, and I've the entire thing I've asked them to shorten down to less than 30 millimeters.
Which they did a pretty good job on. I mean, everything still fits. They kind of know what they're doing. Okay. So the next thing here is we have the Circlip ring. You can kind of see the little ears there. And then Jason's calling this next part the retaining ring. This is what I was calling the cylinder.
Yeah, I'd call that. Like I'd go with retaining ring on there.
Yeah, that's kind of like the fat washer. It's a couple, like 2.5 millimeters thick.
Yep.
Yeah, well, that's where if you want to put more spring tension, you'd thicken that up.
We can't move it lower though, because the sleeve jams against it. So you see how it's flush?
Okay. Yeah.
That's perfect right now. If I try to move this lower, I can't.
Yeah.
We might try to get a better spring. We might, but even then, I don't know, because I think this is compressing a substantial amount. Not fully, but a substantial amount.
Hey Ray, before you take the circlip off, can you see does the sleeve rotate independently of the shaft?
No.
Okay, so there's
like
something.
A fraction of a degree.
Okay.
See, now I'm thinking in order for those balls to return, there's got to be probably some spring steel over each of the balls in that ring. If it's just a hole, there's nothing to stop the ball, keep the ball under tension.
I think it's a slot. What's interesting is as I'm moving it up and down, the ball actually does not move. You can kind of see it a little bit right now. It doesn't move.
It could be a tapered slot. Yeah, that would make sense, wouldn't it?
Maybe. I don't think I can do this on camera, but I'm pushing down, and then if I get in there with a bit, then they'll go in. So right now that thing is in. Yeah, I can see it moving down a little bit. It's like an angle of attack, you know?
Yeah.
So this would be the top position, that would be the bottom position. That's what ended up happening. Does that make sense, guys?
Yeah, tapered. So it's a tapered slot.
Okay. Cool. Any other requests for attempt number 2 of the circlip?
On the picture that Jason put up, there's a 2mm pin that goes all the way through the shaft.
Yeah, that is in there. Yeah, that's in there. I was wondering if that was this screw here or not, because it seems to be farther down.
No, I have discovered what the pin is for. The pin is there to basically retain a filter. So if you get on Taobao and search for Juki filter, you'll find these little white filters, little cotton filters that you can push down inside the shaft. And the filter sits on top of that pin. And I guess it's designed to keep anything from being sucked up into the motor.
Yeah, like a cigarette filter, I'm guessing.
Yeah, exactly. And I'll find the link to one right now and paste
go ahead
it
and
into the
screen
chat.
share, and I'll pull up your screen as main. We can take a look. In the meantime, see, the thing is, I actually have to expand this as opposed to squeezing it. So without the proper tool, it is extremely
you're trying to do it with a pair of long-nosed pliers.
Yep. Try to expand it. This is the direction that it doesn't want to go in.
All right, I've pasted a link to that filter into the chat if anybody's interested in seeing that. It really does just look like a cigarette filter.
Do you just want to share your screen? That way everybody can see it?
Sure, happy to. Let's see. All right, and is it visible?
I think it's going to take a moment to come through. I've just got a black screen right now. Okay, so now I see myself. There we go. So is it like a little cotton ball or something?
Yeah, do you see? Let me click on the picture here. No, that didn't work. Let me see. Do you see this Taobao screen here at all?
Yeah, I see the Taobao.
Okay, so yeah, here it's right here. It looks like they don't have a larger picture of it, unfortunately. But yeah, it looks like it's just a small cotton filter that you can shove down in the shaft there.
Got it. And would that be coming in from the motor side or from the Juki Nozzle side?
That I'm not sure about, and we may be able to answer that as you disassemble this further.
There may be one in there.
There very well may be.
I can guarantee that.
Yeah, when I asked the company to shorten the adapter down to 30 millimeters, they came back and said that it was impossible because of the filter. And I said, "What filter?" and so they said that that's what they called the pin a crossbar, and they asked me if I needed the crossbar. And then I found that filter and kind of put two and two together, realizing what they were talking about.
Yeah, see, I would just tell them, look, we need it as cheap as possible, but still accurate. Make it happen.
Yeah, I'm afraid that will result in something that does not work at all.
Yeah, that's true. Well, yeah, we can do it for $15, but you're never going to see it, and it's not going to work.
Yeah, exactly.
My experience with the Chinese is that they will always tell you yes, even if they can't do it.
Yeah. Dirty PCB.
And the Taiwanese are very similar. I requested some. I use a lot of ceramic resistors in crossover parts, and I wanted basically a 5-watt ceramic casing, but with a solid wire through. So there was no. It was just literally a link wire. So we went through, and they kept coming back and asking, well, how long should the wire be, and how much each end? And I said, I don't care. Just as long as I've got 30 mil out of each end, it doesn't matter what it is. So they did them, and they sent them through, and they printed them as 5-watt 0 ohm. So they made them, but
yeah,
it wasn't easy.
Ray, on the back of that Circlip, basically away from the open ends, a lot of times there'll be a little slot that you can get a screwdriver into. Do you see that on this one?
Not really.
Oh, okay.
2 ears. Maybe it's on the bottom, but I don't have enough of an angle yet to see clearly.
you may actually be able to split that out just by putting a screwdriver, a flat blade between it and twisting it to get it to jump one side over the groove.
I think I've already accomplished that. Actually, I think both sides are over the groove now.
Oh,
I don't know if the back is, though. Yeah, it is. Yeah, everything's loose. Cool. So I can just pull this out and hopefully it'll fall. Yeah, there's no indication that I didn't get this far the first time. I have a feeling that my logic was, yeah, I don't want to scratch the whole shaft, so I'm just going to put this back together and wait until my machine's filled.
Well, thank you for taking the risk this time.
Sure.
Oh, there you go.
There you go.
So
Looking
John from Chili Pepper actually sent me this one. I would not have spent $100 of my own money on this, but we were talking about the same thing, which is disassembling this thing, reverse engineering it. You're doing it on the 4th axis. So we got a few.
That's spacer.
Okay, so it's actually a shell. It's not a solid washer.
Ah, okay.
Interesting.
Interesting. That is interesting.
Yeah.
Can you
This receives the spring.
can you put some dimensions of that up later? So I'm going to draw this first thing tomorrow morning.
Okay, I want you documenting it now, frankly.
Hold on,
You can rewatch the video if you want, but I'm doing my caliper work now.
I can grab some paper and a pen.
Okay. Outer diameter 16.06.
Okay. So what's the and the thickness is?
I had it at 2.5 earlier. I can confirm that at 2.46.
Yeah, 2.5. And what's the internal?
Yeah, 1 second. So this I want to verify first. 9.42. And then the internal here, roughly 9.7.
Okay. Well, good amount of clearance there.
And what's the
Could be up
depth?
to 9.8.
Call it 9.75 then. What's the depth from the on the back side? So the actual from the face into the cup section.
Yeah, so 1.42 recess.
Okay.
And then I guess that's a 1 millimeter thick. Yeah, that's roughly it.
Okay, that makes sense.
Yep.
Yeah, I don't have a clear way to measure the internal lip, if you will.
Turn
It'll be roughly one.
turn the verniers round the other way, and the end sticks out, and you should be able to measure with it.
Well, I know that's how I measure the recess at 1.42. I'm saying I can't measure the other part.
The thickness of the part that's not shelled, yeah.
Well, that'll be 2.5 minus 1.42.
Right.
Exactly. That's what I told you to do. Yeah, 1.4, 1.5, and then 1 for the
Yeah.
Yeah, and I don't really think any of these are particularly critical dimensions. It's just holding the spring.
Yeah. Okay, now this will not go past. We have a screw right there. This will not go past it, and it still will not rotate.
All right.
Once again, because you're out of focus, you're out of shot.
There we go.
Okay.
And it will
Now-
not rotate. You see, there's a little bit of wobble. That's
Yeah.
Yeah.
Do you want to give
Does
us?
the-
Do you want to give us the dimensions on that spring?
Yeah, so once I get it out, the screw is still keeping it in. So we'll take the screw out, and just for documentation, the lowest loop of the spring only is retained
Okay.
by the screw head. Very slightly. I'm sure if I just like jimmied it a little bit, it'll come right out.
So that screw is actually holding that spring in place.
Not anymore. But there was a tiny amount of overlap. Now this is very interesting. You guys see that U shape? It's like half a slot.
Yeah.
Sleeve?
Okay.
So that's
okay.
actually what terminates it. So that's why this won't go any farther. It's not that it's jamming against the retaining ring.
The screw.
It's that the screw head. So that's what the screw head's for.
And that, well, also I think that the screw head keeps it from rotating on the shaft as well.
Yeah, that's possible because the bit of it, yeah, that's what it's hitting against. The very, very tip.
But then again, with
Very
the three balls in there, it shouldn't move anyway.
Well, I don't
That's a
know.
good question. I think that, yeah, I'll let Jason talk.
Well,
But
what I
I
was
think
going to
it's
say
the
is I
balls.
think that I think the sleeve probably just has a basically an indented ring, and the balls fall out into that ring as the sleeve is pushed up, and then as the sleeve is pushed back down by the spring, that ring pushes the balls back in towards the center of the shaft. That's my guess about how this is going to look.
My answer is going to be, yeah, close enough. Sure, whatever you guys come up with. I'm going to track down some better screwdrivers. So just bear with me a moment. I'll be back shortly.
All right.
Yeah, it's a lot easier to see how it works when you've actually got one apart.
Yeah, this is very, very helpful.
So we should be able to get. I can get this drawn, and then we can just make it an open source part drawing that if people want to machine it, they can.
Yeah, that'll be really nice. And I think since this has been such a struggle to get availability on these, I think I'm probably just going to stock them and sell them.
That makes sense.
Or if somebody else can, doesn't matter to me. I just want them to be available.
Yeah. Because this apart from the head design, this is one of the next critical things, isn't it? It's the.
Yeah, sure is.
Peter did a lovely job on that head.
Yeah, it's nice. I can't wait to see it in action.
I just haven't had a chance. I've been so busy with other stuff at the moment. I haven't had a chance to just do anything.
I'm back. So as you can see, I have one set that actually is organized. And then I have two more sets that you can infer the status of yourselves.
Yeah, you haven't seen my garage. My garage, there are tools everywhere.
I'm actually very concerned about stripping this screw out. So good thing I have an entire series of Phillips bits to try.
It looks like it might have come partially pre-stripped.
Oh crap! Yeah, that's pretty much standard for China.
Yeah. It looks like the head is already a little bit stripped out.
Yeah. Yeah.
Too tight?
Yeah.
I would not be surprised if there's some Loctite on there.
Could be.
So if it is,
I would suggest heating it, but I also don't know if there's any O-rings in there that could potentially get destroyed.
I wouldn't.
No, if there's an air leakage, I would not expect it to come from there. Like that's not the point of failure.
Well, no, what I'm saying is if you heat it, that would release the Loctite, but I don't want to potentially destroy any O-rings that might be hiding inside there that we don't know about yet.
Oh, okay, that's cool.
The only place
translation, let me do it anyways.
Would be between where the nozzle seats inside. That would
There's
get
nothing that's on metal.
Yeah.
Okay.
That way you're sealing the nozzle against the back of the adapter, aren't you? Because the balls are lower down on the nozzle than the furthest point on the nozzle, aren't they?
Right, I believe so, yeah.
All right, let's make this happen. Oh, crap. You see what I meant about the frame shaking. Yeah. All right.
Looks like we've got a Harbor Freight fan in the house.
Not a fan. It all breaks. It all breaks.
I've got the exact same gloves.
I like
I've got
it.
the exact same screwdriver as well, actually.
It's all standard stuff. I've got the drill, the $20 drill that's about to crap out on me.
Yeah, there
I
you
don't think
go.
it's the motor. I think it's the trigger just being, because it's essentially a potentiometer. And I
Yeah.
think it's crapping out. So yeah, there's that.
Yeah, I got a Bosch Professional cordless that's doing exactly the same thing. So and I paid $200 for that one.
Yeah, got it. Okay. All right. $100 down the drain. Let's do this.
I don't think it'll be that bad.
Yeah. So do I have to get the screw out while it's hot, or is this just a one-time
No,
heating
you just need
operation?
to soften the.
Yeah. Oh yeah, this one doesn't like to work. Okay, one sec. Normal lighter. Not a smoker, by the way. Just recognize the utility of having multiple lighters.
I have to imagine that anybody that does any electronics probably has piles of lighters laying around in various places. I know I do.
If this doesn't work out, I have the torch thingamajig, the butane soldering iron from Radio Shack,
Yeah.
and I'm more comfortable holding that than I do this combination of parts.
I had a nice Porter Sol. It was confiscated by TSA at LAX.
Ah,
Of course. Oh, that's a nice effect. It looks like my finger is burning. Great.
I actually sort of broke down and bought one of the cheap eBay hot SMD hot air nozzles for like $30. The ones that everyone said were dangerous and lethal, and it's good. It works fine. I took it apart and checked that it was earthed correctly, and
I don't know which one that is exactly. I spent $50. I got the 2-in-1 rework station. It has the nice fine tip soldering iron. Came with other tips too, and then it's got the hot air blower.
I already had a nice iron, so I just plumped for the just the hot air section.
Okay. See, my previous iron, this was just a few months ago, my previous iron was a $15 station from MPJA.
oh,
And I'm pretty sure I bought it before 2010. So it was time for an upgrade.
I've got a JBC station at home, and then at the office I've got a Weller.
Yeah. Weller makes good stuff.
Weller does make good stuff.
Yeah.
The biggest problem we used to have when I was working for my last employer was when you're soldering a lot of speaker parts, there's always magnets. If you get the wrong soldering irons with bimetals, you get about 6 months on the production line out of them before the bimetal suddenly becomes magnetic and just welds itself shut. And then you start seeing, the iron's just, the whole iron is glowing red.
Oh, Christ. Yeah, guys, I don't think this screw is going to get very far.
Oh man, that's a shame.
Yeah, I don't know how far I want to push it, just because I imagine this is specific enough that even if we were able to forcibly extract it, I would need an extremely specific replacement for this to work. All right.
Could try tightening it and then backing it off. It may just be that it needs breaking free.
Interesting. I think the stripped head definition goes both ways. No pun intended. All right. I think I'll give it a few minutes before I put it down on this. I'm going to put it down on this now. All right, we're good. Okay. just so that it doesn't roll over and burn me. Okay, in the meantime, let's deal with the spring. Graham, you got your pad? Graham, you got your pad ready? Okay. So the uncompressed comes in at, let's say 11 millimeters. And we definitely want to overshoot that if there's any sort of disparity with what we can purchase. We would definitely want it to be a little longer. The outer diameter I don't know, I've got 14.14 or 14 even.
Yeah.
Depending on where you slice it. Internal diameter is coming in right around 12.
Yep, that makes sense.
Okay. And then, as far as counting the number of coils, how do we want to do that? I've got, starting here, about 1 full rotation. And then, well, no, hang on. So starting there, and then, I don't know, what's that come out to, like 2, 2.5? I'm not sure.
Yeah, it's probably 2 or 3, I'd have thought.
Yeah.
It's right in the middle because
then,
the endpoints are 180 degrees of each other. You can't see it. The one endpoint is there, and the other endpoint is there. So 2.5.
When you start searching for springs, you find that they tend to meet sort of very standardized sort of number of windings for the height, etc.
Okay. Ray, can you measure the diameter of the spring wire, please?
Yes, good call.
Yeah, that's going to be critical.
Yeah. Now, are these like 5 or so data points enough to extrapolate the spring force and any other such things?
Should be, yeah.
Yeah. I've got it at 0.93.
Okay.
So 1 millimeter probably. 0.98. Yeah, 1 mil.
Yeah, because I mean, wire size normally. I mean, it would normally be 0.75, then 1 mil would be your next size up.
Yeah. As PCB makers, I really should be more careful with saying mil to mean millimeter.
Yeah.
Old habit just came back.
And then one other thing that might be useful, I assume it's just steel wire that's been coated, but could you check it with a magnet?
Interesting. We'll have to get back to that. I don't have any magnets nearby. Or do I? I should. Anyway.
How about your little flexible doohickey there in your screwdriver set?
Good call. No, I have good neodymium magnets. Almost forgot about them. Yep, it's magnetic.
Okay. Good
so
to
what
know.
does that tell you? That it is steel wire?
Yeah, it's probably just mild steel, and then they've used the chemical coating on it to make it black, it looks like.
Yeah.
Yep, looks identical to the finish of the main thing.
Great.
Okay. I'm wondering if this is cooled down yet. The one thing I don't have from Harbor Freight is a little infrared thermometer, which people really overuse.
Yeah, I have one. It's not very accurate.
I mean, ultimately, if it can tell you if your 3D printer's hot end is at 200 degrees or at 50 degrees, that's good enough for me.
Yeah.
Or, I don't know, like within 10 degrees, I should say.
I've got a good one, but I use it. I use it for checking the heat bed temperatures even all the way over.
Hey guys.
Oh, you got it?
We got it.
There we go. Good.
I guess if I see any color, I'll be able to tell you if there was Loctite. I don't think there was.
Huh. Okay.
Or at least there's no evidence of it on the screw threads themselves.
Yeah, because you normally see red or blue.
Yeah, no,
it may have just been jammed in
there.
there.
Give it another 5 minutes or so. But yeah, that inside looks interesting.
Looks like we're sliding up there a little bit.
No pun intended, I'm sure. Yeah, so that's still fairly warm, and I want to handle it with my bare hands. So about 5 minutes, okay?
Okay. Yeah, so one thing that's interesting about this is I like that screw keeps the shaft from, or that keeps the ring from rotating on the shaft, because
Yeah.
I was always curious about the flats on that ring, and I think the flats are intended to be the place that you slide into for doing auto change.
Yeah, that's what I was thinking. Yeah. What's the? Can you give us some details on that screw?
Yep. So diameter 1.9. So I'm assuming it's an M2,
M2.
which it is because we know that from Jason's drawing.
Yeah.
Uh, the head is 3.3, roughly. Can somebody pull up a Bolt Depot and share their screen, please?
Yep. And can you measure the length under the head to the end?
Yep. So I've got 2.5, roughly.
M2 by 2.5. Okay.
Yeah, and then
And what's the head shape? Is it a pan head, a cheese head?
It's yeah, whatever the circular one would be. I think that's pan head.
Can you show it on screen a little better? You're out of the frame right now.
Oh, I know. Yeah, because my eyes are here, not down.
Yeah, I understand.
Let that come into focus a little bit. It's not going to happen.
There we
Hang
go.
on. Oh, it worked? Oh, no, I was just going to... Yeah, you're not going to see anything right now.
Okay, it looks like it's a pan head. It's got a slight dome over the top rather than a flat top, yeah?
Yep, it fits the pan head description, indeed.
Okay.
All right, you said you wanted to see Bolt Depot, right?
Yeah, let me pull up your screen, indeed. So, under metric, machine screws.
Machine screws.
Under metric, not US.
If we're going to
Scroll
do this
down.
ourselves, we should really switch this to a Torx head screw.
Yeah,
agreed.
Or a hex head is my preference.
No, hex heads tend to round out. I've learnt that over years. Whereas Torx, there's less chance of it rounding out, because once it rounds, you're screwed, especially on a small screw like that.
Okay.
So it looks like they have 2mm and 3mm lengths.
All right. Let's get a new tab going with McMaster Car, please.
Yep.
I'm just checking my supplier in the UK because.
Yeah. So screws and bolts, and then I forget where Torx is going to show up. But let's just go with the pan head of the metric variety. You got it.
Yeah, it looks like they've only got 2 and 3 as well. And you said you measured it as about 2.5?
I did, yeah.
Huh.
Now,
okay.
One of the original impressions I got is it kind of looked like the bottom of the end of the screw was ground down a little bit or something of that sort. So
that makes sense.
This is definitely closer to 3, guys.
Yeah.
This is definitely closer to 3. I've got 2.89 now.
Yeah.
And I feel like I don't know, I'm not getting under the head completely or something. That could be it. But we're not risking anything by going lower. We're good.
I'll tell you who may have those. Misumi. Extrusion and everything. They may well have something that small.
Cool. Jason, can we keep on McMaster Car for another minute?
Oh, yeah, sorry about that.
Yeah, no problem.
1 second. Let me reshare.
Yes, please.
All right.
Okay, so if we narrow it down to 3mm length.
Oh, yeah. 3mm length.
And then I think we can remove the criteria for Phillips. Although I believe that was one of the fundamental ones. So I guess we'll just leave it. So just stay on the screen that you're at right now. Sorry about the confusion. And then what material do you think we're going to want, Rain? Because we can get black oxide stainless right off the bat.
Yeah,
if we want to go all black. But this is probably, I don't know, I'm half and half. Kind of looks like stainless. But knowing them, it could easily be zinc. Doesn't really matter. Same sizes.
I really don't think it's a critical screw, to be honest with you.
No,
I don't think it matters.
So in that case, I'm just interested in the sizes. So why don't we go ahead and pull up the stainless one, which is the second option on the left.
On the left.
One
yeah.
lower. No. You were there. Sorry. Okay. So
Right here, stainless.
No, so I'm interested in the first column that reads metric pan head Phillips.
Oh yeah,
Blah, blah,
right.
blah. And the second option there was 18/8 stainless steel, so one lower. Yep.
Yeah,
And then hit the 9 whatever the product number there, just a little bit to the right. There you go. And then product detail. You could open that in a new tab or not, doesn't matter. Okay. Okay, so that's what was interesting to me, is that they're reading out 4 millimeters as the size of the screw head.
Mm.
Okay.
And what did you have?
I had 3.3.
3.3.
Yeah.
All right, let's back
Can
up
we
a
go
little
back
bit.
to Bold Depot for a second?
Yeah.
Because nobody considers the head diameter critical. So, yeah, like, you're not easily going to get to specify that one. Okay, so Phillips pan head, doesn't matter, stainless. 2.
Yep.
That's a 2 millimeter. And then length, okay, 4 millimeters, no problem. Bolt Depot has a more limited selection
Yeah.
for instances like this.
I'll see if I can find a smaller head anywhere.
No, Jason, that's fine. If you can go back to Bolt Depot, I don't care what the length is. I just want to see what their head diameter is.
Yeah, just to see if if it had been modified from something that was.
Okay, yeah, so head diameter in the chart 4. Okay, so that's standard.
3.7 to 4, yeah.
But not 3.3.
Well, here's the question: does it actually need to? Yeah, it does have a head on it because it's holding the screw in place, isn't it? I mean,
Yeah.
holding the spring in place.
Let's.
Well, I don't think it's
copycat.
I don't think it's particularly important that it's holding the spring in place, but it does keep the sliding ring from rotating, and so it has to fit within the slot of that ring.
So
Yes.
why not go to maybe go to a set screw instead?
Yeah, I was thinking the same thing.
Interesting, but then that would be 2 millimeters everywhere. We could use 4 millimeters. If we're going to be manufacturing this ourselves, then we just make that half slot, we just make it 4 millimeters.
True.
Yeah.
Nice and simple. Now this is rotating, by the way. Now. Oh, you can't see it. I can rotate this now. I don't know how much I want to rotate this, but nonetheless I can. Okay, you guys ready to get back to it?
Yep.
Yeah.
And then we'll hunt screws later. Okay. Jason, you're welcome to stop screen sharing now, if you'd like.
Yeah, I have.
Oh, perfect. Okay. So we have this, and things are going to start falling out. So I'm just being real careful here.
Voila.
Well, nothing fell out. Fingers crossed. What we're looking at is there is indeed a hole here, and I can push on the ball bearing from the inside, and it's coming out towards the camera.
Yeah, and I might suggest that you lower that down to your plate and take the 3 balls out before they accidentally come out and bounce away.
I have spares,
I was
but the
just
spares are
thinking
with the intention of making the new one. Now they're actually in place fairly well. Like there's not quite an adhesive, but there's something. There's plenty of oil around here.
Yeah, they may just be held in with some grease.
Yeah, that's probably what this is. Yep, that's grease. Okay. Now you guys understand what's happening, right? So there's no slot. It's just a hole,
With
and the hole has a chamfer.
That's
The
it.
hole has a chamfer, so they can go out and they can go in. Boom.
Just use the neodymium magnet.
Yeah. Nah, we're good. I got it.
All right.
Cool. Give me one moment. These are my clean gloves, so I shouldn't be doing this, but whatever. Okay. So, yeah. Honestly, it's extremely self-explanatory.
Yeah.
There's a hole, there's a chamfer, there's 3 dimensions that we have to pull at the most, and that's it. As for this thing, ugh, well, it's staggered, so there's 2 points, and 2 points of interest.
Hey Ray, do you have a flashlight handy where you could maybe shine some light into that?
I think I see how it is.
Oh, lost you.
Oh, yeah. So if I double tap my iPhone's power button twice, I have it set to turn on the flashlight. However, it just went dark for that same reason. So you can't always win.
I should do that to mine.
Yeah. Yeah, jailbreak's pretty straightforward. I don't know about the latest operating systems, but should be. Okay, we're back. That's good. One more time. Okay, so actively using camera and flashlight, not a good combination, says the iPhone. Okay, first of all, is our view good?
That's pretty good.
Pretty good.
Okay, let me get a flashlight going.
All right, thank you.
So Jason, is the new Raspberry Pi going to be powerful enough to run OpenPMP?
Oh, OpenCV is probably the question that should be being asked, right? Like the reality.
No, actually, really, the UI is the most resource-intensive part of the entire program. It did run fine on actually the original Raspberry Pi, but it was quite slow. So I don't know. It's tough to say.
Okay, guys, before my arms get tired, do you see that there's 2 levels, that there's a stagger on the inside there? Like, I'm purposefully holding it at that angle.
Okay, so it's smooth until that ridge, and then the diameter decreases, and then it's smooth again. Is that what I'm seeing?
Correct, and it's not a chamfer, it's a sharp horizontal ledge on the inside there.
So it's.
Oh, that was perfect. Go right back. There we go.
See it?
So it's literally pocketed out.
Yes.
That's interesting.
That's not how I was expecting it to look.
Yeah, actually, I'm not sure how that works now.
Guys, this is what the Juki seats against. I don't know what the confusion is. Wait, is it? Hang on.
No, it's not.
No.
The Juki sits against the shaft.
Yeah, the Juki sits inside here. Good call. Okay.
So what I expected to see is something that had either a chamfer or an incline that would push the balls back in.
Huh.
Unless maybe does it come up far enough that the balls actually start to come out from the entire surface?
So what happens is this. How do I explain? Bottom line, if I retract this, the balls don't move. When I get in from the inside, then I can move the balls if they're free to move. You can't see them.
Yeah, because the balls are being held in place by the grease.
Yeah. So if I go with the Juki Nozzle, it will displace the balls out. This will displace the balls back in. That is how the tool change works.
Right, I understand that, but what I'm saying is, what part of the outer ring presses the balls back in? Is it the larger diameter or the smaller diameter?
Let's find out. Okay. Free to move. Free to move. Locked.
So are the balls just sitting there, and it's not until that collar comes down that maybe the smaller diameter is contacting the ball all the way through the hole?
I think so. It doesn't lock until the very, very end of the motion to the right.
Can you measure?
That's what it is.
Can you take the nozzle out?
Yes.
And put measure the diameter without the ball, without the sleeve down, and then with the sleeve down, forcing the ball out. I'm curious to see how far the ball is out.
Yeah, hang on. Let me just explain this real quick. So the Juki has chamfers, both here for when it's going in.
Yeah.
And there's a lesser chamfer for when it's coming back out.
Mm-hmm.
So it's not as smooth. That might be just because I have the one ball in it right now. It was definitely smoother when I had all three balls in.
Can you measure the diameter of the ball, please?
Oh, yeah. Sure. Can I do the thing Raim said first?
Yeah, of course.
The internal diameter where the ball is free to move, and then again when it's not. Did I understand that correctly?
Yeah, I'm just curious to try and figure out how much force it's putting on the...
Okay. Well, now the main question becomes if I'm measuring correctly and why the value is not 7 or 6.9. Jason, I'm at 6.86 right now, so it's a caliper problem.
Hmm.
Well, no, not that. Like if I go at the very, very tip, I can get, I don't know, maybe I can get higher. Yeah, like we would need actual hole gauges if we want to get that accurate.
It hasn't got to be that critical, because somebody's just measured the nozzle at 6.95. I'm just curious, trying figuring out how those balls are not, when you push the nozzle in, what's to stop them falling all the way out into the area of the...
Oh, that I can tell you much more simply, because, hang on.
Because the wall thickness is not that great, and if it's a 2 mil ball...
The chamfer results in that the lowest or most close to the center portion of the hole has a smaller diameter.
Yeah, that's right. Yeah, but now what I'm concerned about is on the back side of that. When you push the nozzle in, that ball bounces up, and I'm curious what's stopping it.
It doesn't bounce up; it bounces out away from the central axis. And at that point in time, it's going to hit the wall, the inner wall here of the sleeve.
Of the larger diameter.
That's what I'm curious as to. But actually, the easy option for this is give us the dimensions on that piece, so we can then we know how.
Okay. Let's start with the ball.
This is exactly what the Chinese do to everything, so I don't feel bad about doing this.
Oh no, I've always considered that this is one of my skills. Like, there's a list of things that I know I should not do. This is on the list of things that I acknowledge proudly. 1.97, so it's a 2 millimeter ball. Good eye.
Yeah.
I don't know why I didn't realize that. Okay. Raim, do you want me to start off with the main part?
No, I'm not fussed about that. It's just because we've got the dimensions for that on the drawing. It's the other part that we haven't got.
Right.
Okay, fair enough. I do want to do a few of the main part myself, just to verify against the drawings, plural.
Yep, won't hurt.
Okay, so this thing, outermost diameter, 15.9 to 16.
Yeah, 16.
Yep.
First step, 9.56, 9.49, so 9.5.
Yeah.
Inner diameter, 11.9 to 12.
Okay.
I remember 12 being one of the operative numbers, Jason, in the drawings.
Yeah, I think 12 is the diameter of. Well, no, let me take that back. Yeah, I did see a 12, but I don't remember where.
Yeah, I think 12 is the
This thing. The
There it is,
outermost diameter at the very end.
diameter, widest part. Yeah.
Correct. So we'll have to, I don't know, you guys probably understand tolerances better than I do, but there's going to have to be a clearance there. Just enough so that there's smooth sliding, or somewhere, I don't know yet.
Yeah, and as long as it's a loose slip, it should be just fine. That particular part doesn't have to be very precise.
Okay. Well, one of them.
I mean,
Yeah,
the only critical dimension is the other two internals on that shaft, really.
Yeah.
Well, the outer of the main part and the inner of this small head that I'm holding.
Yeah.
Now, I don't feel that the dimensions on what you're holding right now are super critical, because all they're doing is pushing those balls in as far as they'll go.
Well, this does slide. So the internal diameter of this.
Yeah, but it's okay if it doesn't slide. It's okay if it's not a tight fit.
That's fair. Okay, so 5.5 is the depth.
So is that which end are we looking?
Smaller end.
So that's 5.5, and that's what the spring sits over. Yes.
Jason, is it?
Yeah,
my brain
that's
is a little
correct.
lost momentarily. Okay.
Yes.
Sure.
And now,
the whole thing, just to cover our bases, is exactly 15.
okay.
So see, all those halves really do add up.
And then, have we captured the two inner dimensions on that thing, or the two inner diameters? I mean.
Yeah, one sec. You know, this seems to be closer to chamfer after all. That internal thing that we thought was a pocket, because it explicitly says it was. Yeah, that looks like a chamfer.
Okay, then that actually makes 100% more sense.
Okay, good call. So let me just find the point where the caliper starts slipping.
Yeah, if that's a chamfer, then that explains the mechanism completely.
Okay. I think it stops at the point of the step. Because of that outside point. And then I've got roughly 5.7 from here as to where it starts.
Okay.
So that's not standard, that's farther down actually. I can draw that for you guys later, I can't explain it very well. But it's
I understand.
We've got the step here, but this isn't the central point of the chamfer. The chamfer would be one half of its width down. That would be the central point of it.
And the chamfer's easy to calculate because we know what the internal, the front width. What's the width at the front again? We said that was 12. No, the internal.
Yeah, the internal diameter is 12. Yes.
Yeah. And what's the back side?
11.84.
No, the internal as well.
Oh, okay. And 9.3, 9.4, 9.5.
Yeah, probably 9.5.
Okay. That gives me what the chamfer on the inside will be then.
Yeah.
Okay. What I'm thinking, please tell me if it's the same method of thought for you guys. If I were to go into Inventor and I said I want a chamfer on this, the only thing I would really need to know is like the two heights, if you will, that it starts and ends on. So I don't know how you guys are thinking about calculating it. This is
as long as you know the two. Well, there's a couple different ways you can approach it. You can approach it as an angle, or you can approach it as two diameters and a length, which in this case I think is what we've captured.
Yeah, that's right. We've got a 5.7, which is the start at 12, and then we know that the next point is going to be 9.5, and we know the angle's 45, so we can calculate where that 9.5 will start.
Well, I'm getting you that length right now.
Can you give me the measurement, Ray, across the flats?
Yeah. Well, there's only the one flat, really.
Is there only one? Because I thought there was two flats. Isn't that what the tool change picks up on?
Oh, really? There's only one?
One flat. Yeah.
Huh.
Oh, that's very odd.
No, if you guys watch the video, this whole thing just kind of pushes down against like two fingers.
Yeah,
And that's what moves the thing up.
Yeah, I had just kind of thought that in the video they were using it maybe not 100% completely correctly, but if there's not two flats, then I don't know why there's one flat at all.
Yeah, that's... So what do we want? Do we want to put two flats on?
I have a strong feeling that's suggesting that this half slot was done by hand with a Dremel after the fact. And this little flat right here was telling them, yeah, this is the tangent surface to which that should work out to. Or something very, very Chinese sounding like that.
Could be.
So what's that slot doing then?
I just said it could be an eye reference for all we know.
Okay.
It could be a visual reference. It looks cool. You know, Frank with the Chili Pepper Project, he's been talking about measuring the runout and actually compensating for it, right? So he kind of needs something to zero against. So if there was almost like a little pin probe that would go up against this, like the way you would measure the runout to begin with, right? And then this thing rotates, and then boom, that probe just kind of like moves a little farther in. Boom, now we have this flat surface. Now we have our zero.
No, you don't want to measure the runout of so there's a couple problems there. One, you don't really care about the runout of the nozzle adapter.
Not for measuring the runout, for knowing what like the zero angle is.
Oh,
so
yeah.
This is how you get to that. Yeah, this is rotation zero. And then you go ahead and deal with it visually however you normally would. I was just thinking I would not want to be a P&P operator where I would have to like find a little Sharpie mark and then just always rotate it to that, you know?
I think your phone fell asleep, Ray.
Yeah, I know.
Okay. Yeah, as far as zeroing it, I don't know that there's actually a lot of value in that unless you're trying to retain your nozzle tip calibration between nozzle tip changes. Otherwise, if you're just doing it each time you change the nozzle tip, then it doesn't matter where zero is.
That's a good point. I just realized that I did not account for that. He's using the robot dig style adapter right now. So for him, it's just the one nozzle and it's a static thing.
Yeah.
Okay, well, as soon as I figure out which way the micro USB cable goes into this case, there we go. There we go. That should be charging now. Nope, not yet. Hang on.
So coming back then to the question, do we put two flats on that to aid with nozzle changes in the future? So it keys the nozzle into the bed.
You know, I think it would be a nice improvement, but I don't know if it's necessary. And it is two additional machining operations.
Yeah, if we don't have it at all, I don't see the loss.
So in which case, do we need to have any flat on there at all to start off with?
I don't think so.
Jason, why don't you go ahead and ask the company like what that's for?
Yeah, I'll do that.
And then we'll still not do it, but we'll know that there's something else like the filter that's in play.
I mean, in theory, there's no reason this couldn't be made out of hex bar instead of round bar.
Yeah. True.
That would give us six flat sides, and hex bar is no more expensive than round bar.
True. What occurred to me, though, was, at least for this piece, the widest is 12 millimeter, and in American, that's 12.7 is half an inch.
That's right,
which is a standard round size. So that's very convenient.
Well, it all depends, because if you're buying aluminum, it's still imperial. If you're buying steel, it's metric.
That's And then this one's
just to really
21.
mess with everybody.
Yeah. And then this one's the widest is 21, and well, 25.4 would be 1 inch. Wait, did I do that right?
Yeah, 25.4.
25.4 was 1 inch. Yeah, it just I didn't really realize that that's double the diameter. That's really deceptive looking. Like you wouldn't think that that is double the diameter of that.
So which is which is coming in at an inch?
So this one's 20.
I thought we had that
The
as
widest
16.
thing? No. I mean. Yeah, these calipers really crapped out on me today. Not Harbor Freight, Amazon, thank you very much. You're right, it is 16. So why did I... Yeah, so the calipers, I blame the calipers. They decided to measure 20. Yeah, that is
Okay,
16.
I just want to make sure.
Thank you. Thank you. So 16... Yeah. So we could just use like 3/8 or whichever the next step after 1/4 inch or 1/2 inch. I'm sorry. 3/4. Yeah, 3/4. Just take it all from 3/4.
What you tend to find is when anytime anything's being machined, they always go up the size because they want to take 2 or 3 passes to make sure the material's true. Before they don't rely on the. I mean, titanium, for instance, before you even start machining it, they grind it cylindrical and then machine it.
Cool.
Hey, Ray, can you measure the distance from the bottom that the ball bearing holes are?
Yeah, let's do that. Okay, so we have 2 definitions of bottom. We have the inside of the lip, and then we have to the actual bottom.
Either way, as long as we know the thickness of that lip, I'll take either.
Okay. Well, the lip, let me zero this out first.
It's supposed to be 2 point something, isn't it?
2.5, yeah.
2.5, all right.
And then from the bottom, I'm going to rough that at 4.5. Center to bottom edge, bottom face.
So I'm going to compare that to a nozzle. And the thing that I've been wondering about is whether or not they seat the balls directly in the center of the slot on the nozzle or not.
So what did you have that dimension as, Ray?
4.5.
Yeah, that's what the drawing you sent me says.
You guys see where the 2 ends of my caliper are?
Yeah, I'm doing the same thing right now, right?
Okay.
So the interesting thing there is that if that hole is at 4.5, then that means it's actually above the center of the slot on the nozzle.
By 1/2 millimeter or so, because I remember that value as being 5 from edge to center line.
Yeah, so I'm getting about 4.15 of that measurement that you were just taking.
Oh, I'm thinking from the other end, dude. Hang on. Yeah, 2.5 maybe from... Yeah, I'm on from the very end, is what I was thinking.
Okay, yeah, so that I get as... That's harder to measure because it's further in, but what do you get if... Yeah, that one. What do you get there?
I'm at around 4.2 right now.
Yeah, I'm 4.2, maybe 4.15.
Yep. 4.13,
Okay.
maybe 4.1 even.
So what that tells me is that here, let me see if you guys can see this. Can you see my screen?
Let me put you up, everybody. Yeah, go ahead.
Okay, give me a second. Let me find my tweezers so I can point something out here. All right. So let's see. This is going to be a little difficult. Tell me if you can see this or not.
That's good.
Okay, so I think that the ball actually rests more towards here than it does towards here or to the center.
Correct.
And yeah, and the reason for that is so that it pulls it up and puts positive pressure on the base of this to keep it straight.
Yeah, well, that would make sense, wouldn't it? So it's actually sitting on that inside inside chamfer on the nozzle.
Exactly. No better way to line things up when you got three balls 120 degrees apart. I mean, you're really not going to get more symmetrical than that. And by
Yeah.
symmetrical, I mean towards the center line axis of the main thing. Right?
Yep.
It works.
Yeah, that should keep it nice and concentric.
Yeah. Okay, guys. So
All
we
right.
have some things to figure out with this main sleeve here. Not main, just sleeve. Let me go back to my screen.
And I'm just looking at the drawing, and it says the two holes for the bearings. The main hole is 2.5 mil, and the smaller hole is 1.9.
You mean balls, right?
No, this is the hole for the ball.
Yeah,
Yeah.
the hole for the ball.
So the larger on the outside, the main it says is 2.5,
At least.
and then on the internal it's 1.9.
Yeah, I can get as low as 1.7 on this. Let me take a
Okay.
few measurements. Could be the calipers.
Yeah.
Yeah. Yeah, the radius of your caliper jaws are probably too big to actually measure the diameter here properly.
Yeah.
So based on that, if we know that the smaller of the two holes is 1.9, we should be able to calculate how much of that ball protrudes into the
Yeah,
center
exactly.
of the shaft.
That's what I was just thinking.
Yeah.
You guys know the, oh, hang on. There's different internal diameters here. We have one step. And I think there's another chamfer inside it. Or maybe it's a lip, but that's what the very top of the Juki seats against. Inside there. So,
Yeah, I suspect that chamfer is really just to guide the nozzle in during a change.
agreed. It's the very top, though, and the very top of the Juki is chamfered.
Yeah.
So they.
Oh, you're saying that there's a chamfer inside that shaft up top?
Inside?
Right about there on the inside,
Ah.
there is a lip, but I cannot say for certain yet whether it is a pocket style or a chamfer.
Okay.
On the drawing, it's a pocket.
Okay, hang on. I do have an actual flashlight. First of all,
There's the pin.
So much for the flashlight. Yeah. Forget about the pin, guys. By the way, the pin, there's a tiny little, like, dimple there. Just barely make it out.
Yeah.
There we go. We have focus right there. That's roughly the height that it's at. And there's the other hole. I'm on focus. There we go. That's it.
Yeah.
Cool.
Yeah, so I think the filter is actually intended to be inserted from the motor side.
Yeah, so if it's that outer diameter size, then yeah, it would just go right in through here.
Yep.
Yeah. By the way, this is where I hacksawed the additional nub off.
Oh, yeah.
Very easy. I was a little uneasy about it at first. I was like, yeah, so this is a nice $100 thingamajig, nice, good surface finish. It's not oxidizing yet.
All right,
whatever steel
are we
does.
positive that it's steel, actually?
I've been told that it's steel, yes.
Let's see that magnet.
That's good to say.
Good call. Hang on a minute.
Because that cross section you just showed makes it look like aluminum.
No, definitely not aluminum. If I didn't know better, I could say iron. Oh yeah, definitely magnetic.
That's steel.
Okay. All right.
Isn't iron ferrous though?
Yeah, although
Anybody's
iron.
actually machining iron.
Yeah, I don't think anybody's doing that.
Nobody's machining an iron.
Exactly. But if somebody was, I could say it looked like that.
It's probably real low-grade steel.
Yeah, just pot steel, basically.
I mean, these are knockoff Juki parts, aren't they, basically?
Yeah.
I've been wondering about that. Because, Jason, so we were talking about two, you were alluding to a third seller.
Oh, of the Juki nozzles?
Parts. Yeah, so the nozzles, this holder,
Yeah.
I'm aware
So
of two
I'm.
sellers on eBay, and then there's Robot Dig. What do you have?
Oh, I know. If you search AliExpress for the nozzle, there's lots of sellers. Although
Yeah.
the thing that's really difficult about AliExpress is that a lot of these sellers set up multiple accounts. If they get a single piece of bad feedback, they'll just set up another account. Um, and so you have a lot of, things where it's the exact same factory or even the same reseller selling something under multiple names, and it's really hard to tell which one is which.
Yep.
The interesting thing is I actually bought one of these nozzles from a vendor in Shenzhen, just at a booth. I have their business card somewhere, actually. Let's see which one it was.
So you were actually at the electronics market?
Yep. Yeah, I couldn't find any nozzles at the electronics market proper, but I found them in what they refer to as the mech market, which is out in Bao'an. I think this is it here. Let me see. I think this was the company.
S&T, yes.
Let me see. Yep, that was it. Booth 486. So that's where I actually bought my first nozzle from, and then I got 2 more on AliExpress, and then I got 3 more from a different vendor on AliExpress.
Okay. We've gotten everything from eBay. It's just come out cheaper.
Yeah.
But earlier today, I posted a link for the Robot Dig style nozzles, and there was an eBay and an AliExpress seller.
Yeah.
And the background is identical, so it's the same person.
Yeah.
With eBay at just under $25, but you can make an offer, and if I was going to get one, I'd see if they'd do it for 20 even. And then AliExpress is 21, and both include shipping.
I actually tried to buy this nozzle adapter that you're taking apart right now. I made an offer on eBay for $50, and they had it listed for 102. I made an offer of 50, and they came back at 100. All right. So, are there any dimensions we haven't captured?
Oh, there's a bunch. I'm just waiting for you guys to kind of get
All right. Sorry. I'll shut up now.
Nah, it's good. That's my line. I'm usually the one who talks too much. Let me go back to my screen. Yeah. So, the slot.
Oh, yeah.
We can improvise it, because we want all of the portions of the arc to be tangent. And the width, I'm thinking, is going to be between 3.3 and 3.5, based on the screw head. I have 3.4 exactly.
Okay.
And then the depth is almost the entirety of that thing. So the entirety was 5.4 or 5.5 from what I told you before. But
and we said we'd open that slot up to 4, didn't we?
Exactly.
Mm-hmm.
And this is going down to 5 even. So the depth of the arc is 5 even.
Okay.
There's half a millimeter of clearance from the bottom of the arc to the surface.
All right.
Do we understand what I mean by that?
Yep.
Okay. Now, yeah, realistically, we're going to want to make that 4 plus like 1/10 of a millimeter, I suppose. Okay, my video just went down.
Yeah, lost you again.
Apparently my phone is not charging. Wonderful. Bear with me another moment. Yeah, on my workstation, all of the USB ports are really finicky. It's like Smoothie doesn't want to talk. Well, not Smoothie. It's just like all of the Arduinos only want to talk to these 2 USB 2 ports that I've extended. And then there's like the Node MCUs that don't like that, and they want to talk to the nice USB 3 ports on the front panel. And then a bunch of other stuff. But bottom line, USB 3 on this thing is not working out. Okay. One more time. Yes. Video feed, please. Voila. Let's hope that it's charging. Oh yeah, I also have a battery case on, so I can just hit a button and I'll get another full cycle. Anyways, yes, so extending the width from 3.3 up until 4.1, I suppose.
Yeah.
What I was going to say is with Bolt Depot, because that's the majority of my reference, but ultimately I found that screw heads are usually the maximum diameter quoted.
Yeah.
That's it, and they're always under.
What?
Most of the time they come in under that diameter.
No, I'm saying I've usually found that to be very close to the maximum, and then if there's a problem, then they'll be closer to the minimum. But they're usually on par with maximum within a tenth of a millimeter.
And
In my experience.
We decided that's an M2 screw, right?
Yes.
Yeah.
Okay, so I've got an M2 here. I got 1.94 for the diameter of the screw, and I've got 3.80. Wait, hold on. 3.84 is the diameter of the head.
That's right in the middle.
Yep.
So
Okay.
banging that slot at 4 mil is going to be fine, isn't it?
Yeah, sounds like it.
If
And
we
so-
happen to get a screw, sorry, Jason, that's exactly 4. That's going to be a pretty tight fit.
Yeah, and so the thing I was going to say is I'm actually a little bit interested in why they decided to use the slot the way they did. At first I thought it was so that that sleeve couldn't rotate, but as far as I can tell, there's no reason to secure that sleeve from rotating. So I don't know that it actually needs to be a particularly tight tolerance there. As long as it keeps the sleeve from flying off, I don't think it really matters.
That's fair.
Yeah, I'd go with that.
So do we
So
want to
we
increase
can-
it a little past 4?
Yeah, make it 4 1/4 or something.
Well, no, I think 4.1 is more than sufficient.
Sure.
With this particular setup here, the slot was 1/10 millimeter wider.
Yeah.
Yeah, what is with this phone? Hang on. Yeah, so I've just engaged the battery case because apparently nothing can charge this and do things simultaneously. Yeah. I have that $6 USB microscope, so I really should have just used this, but the quality sucks.
No, I think we're getting through it.
Yeah, wonderful. Okay, so, Raim, do you think that we're fairly covered on the sleeve?
Yeah, I think I got enough to draw that.
Okay, and you're good with the chamfer inside it, yes?
Yeah.
Okay, wonderful. If you need one of the ending circles, like the height of one of the ends of the chamfer, I've muttered that enough times. So you just
Got
kind
it.
of go back to this call. All right. Main sleeve. I know you guys have the drawing. Can somebody look at the drawing and tell
Yeah, I
me
got-
about
yeah, I got
that internal step, if you will? The thing that you said was a pocket.
Yeah, it's 6.94 and 9 deep.
Okay. What would be the first measurement that's closer to here?
That should be 9.
That should be 9, yeah.
Yep, pretty much.
Well,
I was
close
getting
enough.
8.9 before, and then 9.2, yeah. Hang on. I still have a feeling that it's a chamfer. Nope. Maybe. I don't know. It's got a couple of lines in it. It's got a couple of lines, so it could be stepped.
You should be able to feel it with your tweezers.
Ah, yes, indeed. Yeah, good thing we've got the plate here. Yeah, let's call it a pocket.
Okay.
Yeah, I mean, to machine a chamfer in there would be, it's it's more work than just to bang a pocket in there.
Okay, wonderful.
Speaking with somebody on the IRC channel who's got some machining experience, he was of the opinion that these holes are probably just reamed.
The ball holes?
No, the primary shaft holes.
Yeah, possibly.
And so that is
which holes are we talking about?
so the two axial holes. So the hole that the motor goes into and the hole that the nozzle goes into.
Okay.
He was of the opinion that they're probably reamed, and so when I told him that I was going to try to get a little undersized, he thought that that would crank the cost way up, because the difference between reaming and boring would cause it to be more expensive. But I am pretty interested to get the inner diameter of the motor shaft hole.
Would you like me to measure?
If you would, please.
Sure. It's not going to be accurate. I don't have hole gauges. But I'm at 4.95.
So the question is, Jason, is it we're going to machine? If we machine this ourselves, why not put 3 set screws at the motor rather than just 1? Is that going to gain anything?
I don't know. I would probably defer to you on that. I have had very little luck getting things to line up properly when I'm using 3 set screws, but I don't have enough experience to really say whether or not that should work.
Yeah, it's such a small amount, isn't it? I mean, really that wants to be an interference fit, doesn't it?
Yeah.
I want it to be snug. I want it to be right on. I don't want it to be, undersized. So the motor is 4.97 outer diameter.
Right.
That's what we were talking about, just
What
directly.
we could do is why not copy the other end?
Exactly, and give it a lip on the inside.
And give it a lip on the inside to sit
against it.
Because the diameter through there, that doesn't really make any difference to us at all, because a vacuum is going to pull whether it be 4.9 or 8.
Yep.
Yeah, we care about it being true.
True on the motor.
Exactly. So.
Okay. That's doable. That's an easy. So
4.5 millimeters in is what you're going to want to do, because it's a 3 millimeter hole for the screw, whose center is, we said, 3 deep, right?
Yeah. Right.
So that gives us 4.5 as the end of the hole, and I don't really have that much more clearance past that. Like, I'm at the end.
Yeah, the shaft. Well, so I use that side of the motor.
I've gone to using this side too. I think if you're using Anthony's printed vacuum piece, he glues onto this side. So you have to use this.
Jason,
what I'm thinking about doing is, yeah, go ahead.
When we're making the vacuum connections through this motor, why can't we just tap the inside of the hollow shaft and use a like a Bolan type connector, like they do for the small airlines?
Yeah, Robot Dig has that. Can you pull that up, please, Jason?
Yeah, sure.
I mean, that's the way I was going to do mine. I'll just thread the inside, and I've got some small M4 airline fitting.
Yeah.
Let's see. Share this. Okay. All right. And you said Robot Dig?
Yes, please.
Their search is terrible. Do you know what to look for?
Yes. So the products drop down, please.
Yep.
SMTNAI.
Got it.
Yep, that would be it. They changed it. And then towards the bottom of this page, you're looking for a little push fit. There it is. You just scroll down to see if we have any other ones. That's probably it, though.
Yeah, I think that's all.
Yep. Rame, that look like what you're talking about?
Yeah.
It looks like they have a picture of it. Yeah, it's being used just that way.
Yeah. thread the inside of the motor and just put that in with a little bit of Teflon tape?
Yep. I can confirm that. Should be a 2.5 inner diameter. Yep, 2.62. Let me switch back to myself here.
Yeah, I've got
On the
2.
data sheet. Sorry, what?
I've got about 2.8 on mine.
Oh, really? Okay.
Yeah, I think that's a reasonable solution. Although, in my opinion, that's a problem that's already solved. I mean, I've got the adapter that I designed both holds the motor and provides the vacuum connection.
Yeah.
So I'm not particularly worried about that. And anything that increases the friction on that shaft is to be avoided because these motors have no power at all.
Yep. Well, the good thing about those joints is the pipe work actually rotates inside of them. There's hardly any friction there at all.
Okay. If you guys can still see my screen, let me just show you real quick.
Let me get that back. Yep, you're good.
Let me just show you real quick the way that I solved this, which I'm very happy with, and it's been working very well for quite some time. Oops, 1 second.
I'm waiting to say, yeah, that's what I was planning on doing.
So, yeah, so this is the way this is oriented when you're actually using it. So the vacuum connection goes right here.
Okay.
These 4 screws hold the motor, and then let me try to make it visible here. Yeah, so this is the lip on the motor here.
Yeah.
And then an O-ring goes in this pocket here, and then the rest of the shaft goes here.
Yeah.
And then the vacuum fitting goes here. And so the way this works out is this O-ring that goes in this pocket is slightly larger than the pocket, and when you tighten those screws down on top, it flattens that O-ring against the shaft of the motor, and you get a perfect seal.
Against the shaft or against, like, the lip?
Against the shaft.
Okay. But the shaft
So basically what happens is so the face of the motor compresses the O-ring, and that causes it to squeeze inwards towards the shaft.
Gotcha. Cool.
So what
is the connection?
Going back to the motor length, shaft length, we're gonna put a little ridge inside this, yeah, so that the motor sits down on it.
Yes.
So do we want to space the end of this off of the back of the motor by a mil?
I'm not sure. If you're looking at my screen, which you should be, just watch the shaft inside the set screw hole. Boom, that's it. Right now it's at the end there. And yeah, I mean, I can go, maybe that's another millimeter or so. I don't necessarily want to. So maybe half a millimeter, and then you start the ridge.
Okay, so what depth do you want this the step to stop the motor shaft going any further?
So that would be 5 then. So 4.5 would be just where the tap ends, but you need some clearance. So 5, 6 is probably too much. So 5.5 at the absolute most.
Okay. Yeah, so on my motor, the back shaft is about 6.6, and the front shaft is about 5.4.
So a step at 5 is going to be fine, isn't it?
5 is good.
Yeah, I think 5 would work.
You said 6 point what for the back shaft?
I've got, I think, 6.6.
Yep, I've got between that and 6.8.
Yeah.
And then the front shaft again, please.
I've got about 5.4, maybe 5.45.
I've got 5.6.
Okay, so pretty close.
Cool. Yep. Not critical, but perfect. Wonderful. Yeah, so Jason, what is the air connection going to that printed piece? Is it a push fit that threads in, or is it a way to capture like a little silicon hose, or what?
I have the hole slightly undersized for the tubing that I use, and I just jam it in there.
Okay. What I was thinking is a combination of what you just showed with the little printed piece that Anthony made, so that there would actually be like a nipple that was printed, and then you could put the hose over it.
Yeah, that would work. That would work out well. The reason that I did it the way that I did is that I use rigid tubing.
Gotcha.
So the tubing that I use is actually for push to fit or push to connect fittings. So it's not very flexible at all. So in this case, it was easier just to push it in.
Cool. Yeah, I have that too. I could do that. That's meant for airline tubing, literally.
Yeah.
Yeah. The nice thing about that rigid tubing is that if you have to snake it through 3 meters of cable chain, it's less likely to get crimped.
Interesting. Interesting. What I'm thinking of, what I have is just very, very thin. It's like a PET tube. It's not like Teflon tubing, because Teflon tubing for like 3D printing, you're thinking like 1 millimeter walls, like 2 millimeter inner diameter, 4 millimeter outer diameter. Those are good 1 millimeter walls. What I have from McMaster is almost like paper thin walls, very, very thin. I could imagine crimping that very easily. But yeah, plenty of good stuff out there.
Yep.
Nylon's probably pretty good. I don't know where exactly the nylon I'm thinking of would fit on the flexible versus rigid, but yeah, whatever works.
I mean, really, you want to try and keep as much of it rigid as possible, and then just use flexible towards on the last, 2 to 3 inches, don't you? Just to.
Yeah.
Yeah, if you need to. Rigid will take a sharp bend, no problem, no cracking.
Yeah, the stuff that I have, I'm saying it's rigid, but it's still quite flexible. Give me a second, I'll go find some. One second.
Okay. Raim, how are we doing on dimensions?
Yeah, I think I got everything I need.
Cool.
I'm going to try and get this bashed out first thing tomorrow morning.
Cool.
I got some CAD time I got to do for a couple of clients for stuff I need to get finished.
Let me just get you taken care of with the Circlip ring.
Yeah, that's on the drawing. Those are
it is?
Yeah, they're pretty standard.
Okay.
I've got it as the Circlip ring is 1 mil and the diameter is 8.5.
I've got 0.72 thickness, so yeah, 1 millimeter if you need to. But yeah, maybe I expanded it because mine's measuring in at 9.
Yeah.
Closer to 9, but yeah, you're right. It would probably have to be 8.5 ish. This. Huh. Hang on.
One thing I do need to check is can you measure from the nozzle face back to where the first part of the notch for that ring? On the drawing it says 16.
Okay, bear with me one sec because I didn't understand. The groove.
The groove.
I have closer to 8.63. It's possible that the jaws are, not getting in all the way. So yeah, we can stick with the drawing, or we can stick with whatever size Circlip we can source most easily.
Yeah. So I'm looking from the groove.
Yes.
To the face where the nozzle would sit flush against. The drawing says 16.
You got it.
Okay.
Voila.
I'm just curious because we've got the reason I ask is the overall height we've got of the part that the balls are kept in, the outer sleeve. We've got an overall height of 15.
I'm lost again. Show me where we're talking about.
we're talking about the sleeve with the slot in with the screw.
This part or
Yeah,
sleeve?
that part.
Actual sleeve.
There we go. No, the part in your right hand.
This is my right hand.
Yeah.
Yes.
We got that at an overall height of 15. Yeah.
Yep.
Interesting. Well, of course, yeah, because the spring sits down and the other bit's cupped. It's all right.
Yeah, so the spring
Yeah,
goes
that's
over.
right. Yeah. My
And then again, the spring is perfect
It's late
inside the
here.
little cup. Yeah.
So, can you guys see my camera? Can you see?
Let me switch you over. Yep.
All right. So this is the tubing that I use,
Yeah, that's the same as
Okay.
I've got.
and there's the inner diameter bit. Nice thing about this stuff is even if you make it that tight, it's still got completely free opening. I think to crimp it, I would have to go probably about that far.
Okay.
So you can very easily do, a 90-degree bend without even decreasing the inner diameter at all.
Cool. Can you smush it in your fingers? Would that?
Yeah, it's pretty tough. So let's see.
It's 150 psi airline hose. It's what they use on industrial machines.
Yeah,
I believe that's nylon, if I recall correctly.
This is 2.39 millimeters inner diameter. It's rated at 143 psi at 75 Fahrenheit, and I can't quite read the outer diameter, but I can measure it. It is.
I think it's 4.
Yep, close enough to 4.
Yeah, 2 and 4 out. Voila.
Yeah. Yeah, I love this stuff. I bought a huge pile of it from McMaster, and I've been using it for years.
Gotcha.
Yeah, my machine shop does a job for. They make one of their customers. They do a filling rig for putting paint in aerosol can, and they use miles of that. So when I want some, I just go down and grab it from him.
Yeah.
I'm just taking 6 feet of this. Okay.
Yeah, won't even notice.
Okay. So, Raim, I'm actually very interested to try 3D printing these parts once you have the design made.
Yeah, I was just thinking about that we could probably 3D print to check that it actually functions.
Yeah. John has a 4th axis for his 3040. So originally we were talking about just putting in some, I guess it would have to be hollow rod, or at least partially hollow, or solid, whatever the case may be, but, round stock, and then trying to do some of it on a 4th axis and then drilling out the internal holes. I don't know. Seems a bit more complicated now because we've got the various pocket depths and whatnot.
Yeah, well, the bearing pocket isn't so much because, most CNCs will index, so you can just give the index for the 120 degrees.
Not that. So when we're rotating, I'm going to put myself back on. So when we're rotating, yeah, so we can do all this on the 4th axis. If this was solid, right, so no internal hole, you put this in a vise and you have to drill through, okay, if it was 1 diameter throughout, but now you have 2 separate diameters and they have a sharp step, a pocket, not angle. So now that requires a very special kind of drill bit or an end mill or a jig to position it in the 2nd position on your CNC, and then go in with a deep enough end mill. It gets very weird very fast.
Yeah, so I'm just thinking one of the guys I may talk to about this. They've got their CNC lathes have actually got mills built on them.
Nice.
So they can actually, and they're twin-headed as well. So they can actually machine the part, and then they move it to the other end of the chuck on the other side, and then they can part it off and then machine the other side. And then they can do the mill work on it afterwards.
Yeah. So they can spin it. They can do a drill operation here.
Yeah, and then drill that.
Yeah.
Yeah, or even mill a flat, whatever. It's the equipment they've got are pretty incredible. But the problem I've got with them is, if you want 100 or 1,000 made, they're the people for it. But if you want 5 done, then it's just not their area.
I
But they
also
also,
cheap.
they
That's
also
always the struggle.
they specialize in stainless steel and titanium.
I wouldn't mind
They've
stainless.
got real machinery.
Oh yeah, it's an operation that runs 24/7. I mean, all the machinery in there. It's got fire suppressant on it for when there's nobody there at night.
Oh wow.
It's all bar fed, and he was telling me that the new machines they've got, they know the tolerancing and they know the material they're working with, so they monitor the temperature of the material to make sure the tolerancing stays true all the way through the operation.
Sounds like aerospace.
I was thinking that or medical.
They do a lot of specialist turning they make a lot of medical joints, medical screws, and stuff like that. But they also do a lot of stainless steel work for making things for correctional institutions, so that they can't get the toilets apart and.
So much for the entire plot of Prison Break, right?
So one note on 3D printing, I dimensioned and then 3D printed the robot dig nozzle adapter.
Same.
So let me find that. If you guys can see my camera, so here's the robot dig adapter that we're all familiar with, right?
Indeed.
So I 3D printed a version of that, which is
Yours
very
looks
hard.
better than mine, to be honest.
Yeah.
That's pretty good.
So, that being said, the main hole here, which I know it's black, it's probably impossible to see on the camera.
No, there's a little pocket.
Yep, so the issue here is that this inside lip right here is a little bit rough, and that roughness, when you actually insert the nozzle like this, causes enough of an offset that it puts the nozzle at an angle like this.
Okay.
Which
There's
creates a
workaround
huge
for
amount of runout.
Yeah. I have a workaround for you.
Okay.
Usually the roughness is because you're over extruding. I know because I primarily print mechanical parts, so I need to over extrude, otherwise it'll literally snap apart. What you could do is put in a G-code for the flow rate multiplier, and just find the layer around which you're almost there, and just do the top 3 layers at maybe like 95%. And that way it's not quite mechanically as sound, but if you're using good filament, you'll be fine.
Okay, that's worth a try.
Yeah. Repeater host is great for going layer hunting like that.
Okay.
I like Repetier.
Yeah.
I was trying to print a job the other day. I got a Simple Metal, which I love. It's a great machine. Brooke did an incredible job there. But it was I was trying to print 2 parts, one inside the other, and it kept trying to force the first what do you call it, the skirt, just to get the extrusion going, and it kept defaulting it to the external of the biggest part.
Yeah, that's how Slicer works.
Which was no good because I was out of print area.
Oh,
So what I did was, I took the big part off and took the G code of the small part, and it put the ring around that. Then I took that section of G code out and pasted it into the part with both parts in. So it printed the ring, and then it went in and printed the small part and then the big part around the outside.
Yeah. There's like 10 other ways you can handle that for future reference, any of which just involve writing your own tiny little bit of G-code that when after it homes, it'll move up. It'll spit out like 10, 20 millimeters of filament, and then it'll retract, and then it'll start your print. So you do it when you're at temperature and all that. And then you just kind of like get there with pliers really quickly and just pull the strand off, and then it starts to print right then and there. All the skirt needs is to prime it, just to make sure that you've got
that's right. Yeah, exactly. That's what I was going for. And I was just like, I can't believe I can't move this damn thing. Okay, I'll physically move it.
Yeah. So that's that. Oh. Yeah, I've been writing, well, Peter, myself, and a couple of other people, we've been trying to get 3D printing into Chili Pepper. Do you guys know Chili Pepper? Like, it's been mentioned enough on the OpenPNP group at this point in time, right?
Yep,
Yeah.
I'm familiar with it.
Cool. Yeah, so it's just been for CNCs for the last 2 years. But I've always thought it would be great for 3D printing. So we've kind of been working on that widget. It works not very well yet, but it does work. I have Slicer running in a cloud service I host.
Oh,
And
cool.
then 3JS is awesome enough that you can actually drag STL files in now. It'll list them out for you. It'll render them for you in the browser. Hopefully next week we will actually write in the plating, if you will, where you can actually like move them around, resize, multiply, all that fun stuff.
Oh, nice.
And then the part of that is it takes, so you can drag multiple files in now, and then it'll actually make a global object, if you will, of all of those, and then make an STL file from that and send that off into the cloud.
That's cool.
So we go to and from 3JS. It's pretty awesome. And then we want to like tie it all together because Frank's working on the pick and place for Chili Pepper. So I don't know. I'd like to be able to print plastic, do conductive in some form or other, pick and place right onto that. They want to do the all-in-one shot of mill a board, dispense solder paste onto it, pick and place onto it, and maybe 3D print on top of that. You know, who knows? But, you know, I'm just trying to tie it all together.
How long before we can reflow as we're placing?
Oh, Frank's been talking about that too. I mean, it's essentially the old reflow oven hack with a Chili Pepper widget. Potentially driven by an ESP8266.
Yeah.
That thing's cropping up everywhere now.
Yeah. So I've been wanting to talk about serial protocols for a while. I was catching up on the mailing list, and I was like, oh, this topic came up again. Oh, crap. Because we go back and we talk protocols every so often. And it's just the same useless debate of I2C, no SPI, no RS485. And I also got tired of it. But the last time, the current one is actually fairly good reading.
Yeah, it's
when you get a group of people together, no one's going to see. Everyone's got their own way of doing things, and my electronics is not that good. I am not a programmer. I can hack things together. If it's a loudspeaker, then come talk to me. But other than that, I just bow down.
Yeah.
Yeah, it's I've been working on OpenPNP for about 5 years now, and that SPI conversation has come up so many times.
All I know is that when I did the analog devices section of my active monitor, it was, they said, oh, you need to use the I2C, and I'm like, okay, what's that?
The I2C, they put a V in front of it. That's big talk.
And they were like, yeah, at the speed you're going at, you're not going to have any problems with, any drop packets or anything. Okay.
Oh, good. Yeah. On my screen, real quick, what I'm essentially working towards is I'm just going to use the term microcontroller as a very, very abstract way of saying just a microcontroller-driven head by itself that can drive the rotation stepper. A servo, because I want, instead of Jason's little lever, I just want a stepper, a servo to move my head up and down, put it on a spring, and then various GPIO. So I had some LEDs and I have a MOSFET board in my drawer. So just all the things that a pick and place head might need, right? That pretty much sums it up in a nutshell. Maybe there's analog inputs, so you could do the pressure sensor right then and there. And then this right now is an Arduino Micro, and I'm just doing this for ease of use. So I can do this using serial over USB. I can use the serial with RS485. I have this talking to the Due over I2C right now. So again, it's the same serial. Or I have Node MCU on another breadboard. There's the MOSFET board. And this can do the exact same command string over MQTT, which is a published subscribe messaging protocol that is much more robust than the ESP hosting its own web server. So
Yeah.
I don't care what protocol people want to use. I just kind of want to standardize the same string. Like, I don't know about the 32-bit firmwares because I'm just getting started with TinyG and Smoothie. I have them all now, thanks to the respective companies. But I'm only familiar with programming Marlin. So in Marlin, I can very easily imagine there being a particular G code that starts with M that would be like, yes, spit out this string on your second serial. You know what I'm saying? And that's it. And that would be like, pick and place / head 0 / GPIO / port 3 / on, right? Or blah, blah, blah / stepper 0 / rotate / 90 degrees. That's it. I just I like that structure. And you can run that over whatever protocol you want. They'll all handle the strings.
Yeah, I think having a simple text-based protocol for it is good. I'm probably leaning towards it being its own G-code interpreter. That way, you can either talk directly to it or you can talk to it as a daughter board. But in the end, it's not really going to matter. We're all basically trying to accomplish the same thing, I think.
Well, I guess I would have to clarify my wording then. So the whole point of the RS-485 would be to be able to daisy chain them in a way that was sound by an engineer's mindset. Cough, I2C, no. Okay. But, I don't know, so anyways, with the M800 series that, Jason, you came up with, right? I'm trying to remember, because I did the same thing. You were talking about you made like a bunch of M800 commands?
Well, I mean, no, I didn't make any. That's just what I currently use on the Smoothie for for outputs.
Right. So I wrote those very explicitly from like M800 to M820 into Marlin.
Okay.
So just the way it would work is those would just send that particular string that you need.
Yeah.
You know what I'm saying? So like if M800 were to be like, rotate the rotation of head 0, or maybe M800 has, the parameters, which number head, so T0, T1, whatever. And then the rotation amount, then you could construct the string that would have, an at head 0, and rotate, and then, 90 degrees or whatever that angle input is. And then that would just send it on serial 1, and then whichever toolhead was on the chain that it applies to would read it, and all the other ones would just ignore it, but everybody would see it. So that
makes sense.
And also because I don't want everything to rely on the firmware, that would be where I was originally saying, well, you don't have to code everything into firmware. There should really be one M code that's just rebroadcasted. So if you just get this code, then you just take that string that's following it, and then you just spit that back out on your serial, and that's like, the hacker's package, if you will. Like, oh, I want to try this, so I'm going to make my own head, and I'm going to add it to the serial chain, and I want it to do this, so I'm going to teach it to look for this one, and then it'll get the commands, and you can do it from there. And that way it's firmware agnostic at that point in time.
Yeah.
So the firmware doesn't care. The firmware is just getting it and spitting it back out. And that way you're doing it all over one serial port or one server or whatever, and you don't have to deal with the second Arduino being plugged in directly to your computer or anything like that. Which Chili Pepper will do, by the way.
What's that? Run multiple at once?
Yeah, so that's actually how Frank's doing it right now, is he's got 2 garble shields, or I think the main one's a TinyG now, and then he's got a little garble shield as the secondary. And we've got a macro that picks up on a pause or just some other comment and knows, oh, this thing, okay, I'm going to send this type of command to the second Arduino, which is on this
right.
port. And then it'll wait for that to finish or somehow, and then go back to the original. So I'd like it all to be handled by one controller, or just anything that doesn't involve a second USB port plugged in. So the ESP is an interesting approach. I don't know. I want all the options to be open out there for people.
Yeah. Yeah. It sounds like a good approach to me.
Wonderful.
Well, guys, I think we've pretty much got this buttoned up.
Indeed.
Yeah. Thanks, Ray, for doing this. I really appreciate it.
Of course. Now I have to watch the whole thing and somehow figure out how to put this thing back together, right?
Yeah.
Somehow.
Looks pretty straightforward.
Yeah, I mean,
Yeah.
I wasn't sure what was going to be in there. You're never sure when you take something apart if there's going to be springs and then there's things firing everywhere and.
I was a little worried about one of the ball bearings ending up in my eye, but all good.
Well, we've all survived, so I think that's a success.
More or less. Sure thing. All right, guys. Been a pleasure.
All right. And so,
Yeah.
Ray, you said this will post automatically to YouTube?
Yeah, so it's probably going to render for between 1 and 3 hours.
Okay.
And then it will be on my YouTube channel, so I will let you know when that happens. We can post it to OpenPNP, I'll post it to Chili Pepper, so on and so forth.
All right. Sounds good.
Yeah, man.
All right, guys.
All right. Thanks a lot. Appreciate it.
Sure.
Thanks.